So we're on to number 8. Number 8 says a local TV station will conduct a survey on the grocery shopping habits of Pueblo residents. People can log into the station's website on Thursday between 8 a.m. and 8 p.m. and vote for the store where they usually shop. The results are reported on the 11 o'clock news. Circle any features that the survey has that might contribute to bias. So let's just see which characteristics the survey has. Is it a simple random sample? A simple random sample would be picking people randomly and asking them where they shop. No, it's not. Is it subject to voluntary response? Do they volunteer their ideas? Well, they have to log into the station. So yes, it's a voluntary response sample. Is it a random sample? I don't see any randomization happening. It's random if we have a list of people and we select them ourselves by some random mechanism, and we're not doing that. We're letting them do whatever they want. So it's not a random sample. It says, are we requiring... We are requiring internet. That's true. The survey is a survey which requires internet. It does. It's not a usual thing you talk about with sampling, that it requires internet. It's just a feature of it. But we'll see whether that might contribute to bias by itself. Is it considered a convenience sample? A convenience sample happens when you have a set of people that you know you can contact easily and you use them. This TV station is using its viewers, so it's a convenience sample. Is it a stratified sample? A stratified sample says you divide the population you're sampling from into groups and you sample separately from each group, like men and women, or freshmen, sophomore, juniors, and seniors, and do a sample from each of those groups separately and combine the results. This is not stratified, no. Is it systematic? Systematic is when you have a list and you pick systematically on the list, every position, every X units down the list, starting with a random spot possibly, or maybe not even doing that. Systematic means choose every 20th individuals if you want 1/20th of the population. This is not systematic, no. We want to know which ones of those things might cause bias. Simple random sampling doesn't cause bias, but voluntary response does, and we're using it. Convenience sampling does, and we're using it. Systematic is good, it doesn't cause bias. Random sampling ordinarily is good, might not cause bias. Requiring internet could cause bias because you're not getting... Oh, sorry, this doesn't cause bias. Likely cause bias. Random sampling is good, so these are good ones. Good. That's good. That's good. Stratified is also good. And the other ones cause bias. Those three. So the three things we have there, it's a voluntary response sample, it's a convenience sample, and it requires internet. Likely cause bias, whether that bias influences how they shop. People that call in are more likely to shop at King Soopers. People who are local TV station watchers are more likely to go to Safeway. I don't know. If you have internet access, you're more likely to shop at some store or the other. If that's true, then you're not getting an accurate idea where people shop by having them call in if they're ordinary TV watchers, and then have them log in. First they have to know about the sampling technique, so they have to be watchers of the TV show, and then they have to decide to do it, and then they need internet access in order to carry it out. And those three things could cause bias. We're on to number 9. 9 says distance versus time for students, 6 CSu-Pueblo students. We think distance might be responsible for how long it takes to get to school. So we'll take distance to be explanatory and time to be response. And that means on the horizontal axis we always put the explanatory variable on a scatter plot, and the vertical axis we put the response axis. So we're going to put distance here and time there when we make the graph. So let's make sure I did it right. So the distance, say if 4 has a time 10, here's the 4 here, and over here is the 10 that correspond to this data value. And that guy there then is this pair here in the data set. So you just keep doing that for all the values. you get a plot. And then if you put those in your calculator, which I did, and if you run diagnostics on to make sure the R value is created, it'll tell you what the correlation is. It says 9649. It also gives you R squared. R squared is not the correlation. It's R squared. R is the correlation, so you want 9649 as the correlation answer. R squared is 9312. R close to 1 and positive says close to linear and with a positive slope. If it's R close to -1, then it'd be the relationship has a negative association close to linear, because the minus R is a negative association plus positive R is a positive association. R squared tells you the strength, what fraction of the variation is described by the linear pattern visible in the data. So it says 93% of the changes, the variation in Y, is due to the fact that it looks like X and Y are linearly related according to the graph. Does changing units change R? No, changing units doesn't change R. So if we decided to change the distance to kilometers and the time, I guess that time is minutes, to hours, and computed those values and then ran that through the calculation for R again, we would get the same answer for correlation of 9649. Over here I've got another scatter plot. It's temperature versus electric bill. We think the temperature, it is outside, has some impact on how much it costs you to pay your bill that year, that month, or that period of time, whatever the average temperature was during that time. Monthly average high, I see. So the average high is 40. You don't have a very high electric bill. Average high is 100. You have a pretty high electric bill. We're thinking that is happening. We did a plot, and here again we have some values. Just pick one. 98 and 132. 98 and 132, I suppose it's this one here. 98, 132, like that. The 98 is the temperature, it's the explanatory variable, and 132 the response, the cost of the bill. So that makes sense. I made that plot. You get that pattern. It says, describe the shape, form, and direction. We missed one thing. How strong is it? So shape or form, turns out it's curved. I'm thinking over here, with these temperatures, you're really not using your AC very much, and so you have about the same bill of maybe $75, $80, or $50 to $80. And then after that temperature range ends, you start having to run your air conditioner more and more, so we see the cost going up and up and up. Overall, it turns out to look like a curved shape. It might just be two linear shapes, I don't know. We don't have enough data to really tell. I would say curved. The strength is pretty strong. The strength is how well can you predict the cost from the temperature. So if I know the temperature, I know the cost to within however this far is. It's about $25. So for any, over here it looks like I can predict it even better. But overall, knowing the temperature, I do a pretty good job of predicting the cost. Low temperature, low cost. Higher temperature, higher cost. Over here, all of a sudden the temperature goes up and up and up. Direction of the association, positive. Positive just means larger X goes with larger Y. Alright, and then I skipped ahead because the next problem just wouldn't fit in the space available to number 12. Number 12 is about a question where you've got some percentages of students in different categories. 58% women, 25% have scholarships, 10% are women with scholarships, so 10% of students are women who have a scholarship. Here's my Venn diagram. We can label it immediately with the 10% of women that have scholarships. That's an overlapping area. And then from there we can work our way out to the outside. 58% total are women, so the total of these two cells, the 10 plus whatever went here, has to be 58. That makes 48. 25% have scholarships. We already have 10 for women. 15 more makes 25. And if we take these three together and subtract from 100, I get 27% out here. 27%, well, 27% here, don't have a scholarship, you're not a woman, you're a man without a scholarship. Then it asks you, what percent are men? Well, the men are not women, so if 58% are women, 100 minus 58, which is 42%, are men. Or we could just take these two cells here and add them together, you get the 42%. What percent are men with a scholarship? Here's the scholarship wheel here. Here's 10% of the population are women with scholarships, so there's 15% left out of the 25% that have scholarships, so 15% are men with a scholarship. We did that. Making some progress through these sample questions. I'm hoping when it comes time for the exam, these help you out a lot. And even if it turns out not to be true, I'm still committed to helping you get as high a grade as you can on the test, and this is what I'm doing right now to try to help you do that. And we'll get one more slide done here in a minute.